AMC 10A 2004, problem 8. We have this game where the person with the most tokens must give 2 to the other people with the least tokens, and then put 1 in the discard pile. This pattern continues until one player runs out of tokens according to this pattern, and we're starting off with ABC, starting with 15, 14, 13 tokens respectively, and we're trying to find how many rounds there will be in the game. So if you do not understand a similarity that's occurring within the question, play out some scenarios. Don't be afraid to solve the question. So if you have 15, 14, 13 to start out with, that's ABC respectively, then A gives 3 away because he must put 1 in the discard pile and give 1 to the rest. So 15, 14, he will have 12. And then 15 must give 1 to each, so this becomes 13, and 15 puts 1 in the discard pile. 15 minus 3 gives us 12. And then 15 must give 1 to each, so 14 and 13. Then he must discard 1 to the discard pile. Subtract 3, we get 12. And now we can stop here and appreciate the similarity. That is the 15, 14, 13, and then corresponding to 14, 13, 12. Now, you could have also seen that we have 15, 15, 15, or 12, 12, 12. You might be seeing this pattern and other patterns as well, but any pattern that you see, as long as you understand the pattern and the logistics of finding out the pattern, then you're fine. If you cannot control the pattern, then it's not a good pattern. But if you can control it, that's a good pattern. But just to make sure that our pattern holds, let's play out this scenario one more time. 14 gives 3 away, 11, 14, 13 puts 1 in the discard pile. Now, 14 gives 1 away, 12 gives 1 to 13, 14, subtract 3, 11 puts 1 in the discard pile. And then 14 gives 1 to each, 13 and 12, 14 must subtract 3, 11 puts 1 in the discard pile. And we see here again, 13, 12, 11, another correspondence between the previous term subtracted by 1. And what is the total net loss of each? Well, the total net loss will be the total of each of the number of tokens put in the discard pile, because that's the amount that they're losing per game. And we see that for every set, we're losing 3 tokens. That could have been deduced easily as well, because this term in its previous term compared to will each have 1 less. So if 1 less for each player, we have 3 players, they would have had a net loss of 3 per game. So given this pattern, we can continue it along and along and along. So this is 14, 13, 13 becomes 14, 13, 12 becomes 13, 12, 11. I can see where this is going. This can go all the way to 3, 2, 1. But when we get to this point, we must notice and be careful about where to stop. Because after a set of 3 games have run, 3 must give 3 away to get 0. So we don't go to 2, 1, 0. This is a trap. Do not fall for it. Because the next turn, 3 must give away 3 to 2 and 1 and put 1 in the discard pile. So 3 will have 0. So immediately after this round, the game will have stopped along with this token. So how many rounds were there from 15, 14, 13 to 3, 2, 1? Well, we see here that this is a pretty neat arithmetic series. We can go from 3, 4 all the way to 15, or we could choose 2, 3 all the way to 14, or we could have chosen 1, 2 all the way to 13. Now, I'm going to choose the latter, or the third one, because it's already written in starting from 1 all the way to 13. Any number or arithmetic series starting with 1 ending to n will have n terms. So immediately from the third arithmetic series, I see there are 13 terms. Now, how many rounds do each of these patterns correlate with? Well, to get from here to here, we must have lost 3 tokens. And in order to do that, we must have gone through 3 games. So 13 times 3 will be the total number of rounds that have occurred, which is 39. But notice here that we must add the latter one, this solution. Because after we get to 3, 2, 1, 3 must give away his 3 tokens to end the game. And that is 1 additional round. So instead of 39, we must plus 1 to include the final round, which is 40. Bringing us to answer choice E. And you see here that this is a trap answer. So when you see such a correlation within the answers, be extra careful, because the answers there are intentional. And you could have done the same with the circled red pattern, where it's 13, 13, 13, 14, 14, or 13, 30, 13, then 12, 12, 12, 11, 11, 12, 12, 13, 13, 13. But this pattern will go on, and this would be a recursive series, so it would be a little more difficult to solve, but it's not impossible. And I encourage you to try it if you want to be adventurous. But nonetheless, the solution is answer choice E.